Okay, last one, number 6. Consider the differential equation dy dx is 3 minus y cosine of x. Y is a particular solution to the differential equation with the initial condition f of 0 equals 1. Portion of the slope field is shown. Sketch a solution curve through the point 0, 1. Well, here's a point 0, 1. And we want to sketch the solution that goes through that point. Well, this is just a matter of kind of following the flow of the curve of the solution. That's what these marks are. These marks are the tangent line to the solution. So you just want to kind of go down and try to get this just reasonably close. As long as you get that pretty close, you're in good shape. Okay. So there's A, plus 1 point. B. Actually, I'm going to do B down here, and then C we'll do on the right side, because that's going to be the longest part. So plus 1. Write an equation for the line tangent to the curve in part A at the point 0, 1. Use the equation to approximate f of point 0, 2. So, equation of tangent line, well, there's my point. How do you find the slope? By plugging that into the slope up here. So the slope of the tangent line is going to be 3 minus 1 times the cosine of x, which is 2 cosine of 0, and the cosine of 0 is 1, so it's going to be 2. So my tangent line is going to be y minus 1 equals 2 times x minus 0, or y equals 2x plus 1. So this is the tangent line at x equals, well, at 0, 1. And then it says to use that to approximate f of 0.2. So f of 0.2 is approximately equal to 2 times 0.2 plus 1. 2 times 0.2, 2 times 2 is 4, 0.4 plus 1 is 1.4. Okay. Oops. Got it? Okay. B. Or I should say C. C says find f of x, the particular solution with that condition. So we want to actually find the equation of this guy right here. So let's solve this equation. Oh, by the way, this is worth 2 plus 1 for the tangent line and plus 1 for this. So there's 3 points. So this is worth 6. Part C is worth 6 points. Okay, I know in class I said, hey, they're always worth 5. Well, 6 in this case. So a lot of points for being able to solve differential equations here. 3 minus y cosine of x. So we have to separate the variables. So you got to get the y's on one side, the x's on the other. So dy equals cosine of, oops, I can do this all in one because you guys are good students here. Divide by 3 minus y, multiply by dx. So I got dy 3 minus y cosine of x dx. Okay. Now, I can go ahead and do this. I'm going to take the integral of both sides. I can say, okay, this is what q equals 3 minus y. du is minus dy minus the integral of du over u. So this is minus natural log absolute value of u, which is 3 minus y. And the integral of cosine of x is the sine of x. You can always check that by taking the derivative sine as cosine, go backwards, plus a constant. Of these 6 points, the most you can get is 3 if you forget the constant, because it's 1 point for separating the variables and 1 point for taking the correct integral of both sides. if you don't forget the constant, the rest of the problem you get 0 points for. Okay, we want to find the constant, so I'm going to substitute initial condition x equals 0 and y equal 1. So we get negative natural log of absolute value 3 minus 1 equals sine of 0 plus c minus natural log absolute of 2. Sine of 0 is 0. So c is minus the natural log of 2. So now I've got this. Minus natural log absolute value 3 minus y equals sine of x minus natural log of 2. Now, I've got to solve this for y, okay, because it asked me to. Sometimes it doesn't, but most of the time it does in these situations. The problem is I've got this absolute value thing. I got to get rid of the absolute value and figure this out. So notice this. Is this going to be positive or negative, or do I need to worry about the absolute value? Well, if x is 0, when you plug x equals 0 into here, and I'll write this out, when x equals 0, you get the sine of x, sine of 0 is 0, so you get negative log of 2. This is a negative number over here. Negative log of 2. This over here is the natural log of 3 minus 1, which is natural log of 2. This is negative natural log of 2. This needs to stay, this is a positive number here. So I don't need the absolute values. I don't want the absolute values. I mean, the absolute values aren't necessary anymore. So when x is 0, 3 minus y is positive. So absolute value not necessary. Okay, so I can go ahead and eliminate those and just write them as 3 minus y equals sine of x minus natural log of 2. And I'm going to go ahead and solve for y now. So if I rewrite this as an exponent, I'm going to multiply by negative, so I get natural log of 3 minus y equals natural log of 2 minus sine of x. And then this is base e, so it'll be 3 minus y equals e to the natural log of 2 minus sine of x. Again, solving for y. I'm going to go ahead and add, just think in my mind's eye, add the y and subtract that, so I get y equals 3 minus e to the natural log of 2 minus sine of x. Now, I think that's okay. If you leave it like that, I'm going to go ahead and write one more step in case you see it written differently. Or write a couple more steps. This is 3 minus e to the natural log of 2 times e to the negative sine of x. And e to the natural log of 2, those cancel because they're inverses. So this is y equals 3 minus 2e to the minus sine of x. This is the most concise answer you have, but if you left it like that, I think you'd be fine. Okay, this is worth 6 points. Okay, it's part of the problem. So it's plus 1 for separating, plus 2 for taking the correct integrals, plus 1 for the constant, plus 1 for plugging in the initial condition. So of the 6, there's 2, 3, 4, 5 of your points, and then you get plus 1 for down here, for this part. Okay, so you can get the lion's share of the points for just doing the right integral, separating, doing the right integrals. Okay, there you go. That is the test.